Scattered across open seas and sheltered coastlines, floating cages have become one of the most important tools in modern food production. What looks like simple rings on the water are in reality highly organized farms raising millions of marine animals at once. These structures are not experiments. They are the backbone of a global aquaculture industry, worth billions, designed to meet rising seafood demand while pushing farming further offshore. And the story begins close to shore with one of the most delicate and valuable species raised in cages: lobster. Lobster farming operates on a razor-thin margin for error. In coastal waters across Southeast Asia and parts of Australia, lobsters are raised in small floating cages tied together into rafts. Each compartment holds only a few animals because lobsters are highly sensitive to heat currents and water quality. The most dangerous moment comes during molting, when their shells soften, and survival depends entirely on stable conditions. A sudden temperature change or pollution event can wipe out an entire cage in days. But when conditions are right, the payoff is significant. Mature lobsters can command premium prices on export markets, turning fragile cages into lifelines for coastal families. Lobster cages may look simple, but they represent one of the most unforgiving forms of marine farming, where patience, constant care, and environmental awareness decide success or failure. Salmon farming represents the most advanced form of cage aquaculture. Far from shore, massive circular cages hold tens of thousands of fish, all monitored continuously by underwater cameras and sensor networks. Oxygen levels, water flow, temperature, and feeding rates are tracked in real time, turning each cage into a floating smart factory. This level of control allows farmers to manage growth, reduce disease risk, and predict harvest volumes months in advance. Automation replaces guesswork, ensuring consistent quality at global scale. That reliability is why salmon has become a staple worldwide, from sushi counters to fast casual meals, supported by an industry capable of producing millions of tons each year. Salmon cages set the benchmark for modern aquaculture, data-driven, scalable, and engineered to meet global demand with industrial precision. Bluefin tuna pushes cage aquaculture into controversial territory. Unlike salmon, tuna are not reliably bred in captivity. Instead, young fish are captured in the wild and transferred into enormous offshore cages where they are fed intensively for months to increase fat content and market value. These cages are massive, more like underwater arenas built to contain fish that never stop swimming. The payoff can be extraordinary. Once harvested, a single bluefin tuna can be worth tens or even hundreds of thousands of dollars at auction, especially in premium Japanese markets. But this model comes with trade-offs. High feed requirements and dependence on wild stock raise serious sustainability questions. Even so, tuna ranching continues to expand, driven by demand and ongoing research aimed at closing the life cycle in captivity. Bluefin tuna farming sits at the edge of aquaculture innovation, where profit technology and environmental limits collide. Sturgeon farming is not about speed or volume, it's about patience. These ancient fish grow slowly, often taking 7 to 10 years before they are ready to produce caviar. During that time, they are kept in carefully controlled cages or tanks where water quality, temperature, and stress levels are monitored with extreme precision. When the fish reach maturity, the process becomes almost surgical. Eggs are harvested in sterile conditions, graded by size and texture, and handled with absolute care. A single mistake can ruin years of investment. That's why sturgeon farms operate more like laboratories than traditional fish farms. Each kilogram of caviar can sell for tens of thousands of dollars, turning every cage into a long-term commitment rather than a quick return. In sturgeon farming, value isn't measured in how fast fish grow, but in how long producers are willing to wait. Oyster farming is the quiet opposite of high-tech aquaculture. There are no feeding systems, no complex machinery, and no artificial inputs. Suspended in baskets or trays within floating cages, oysters survive entirely on what the ocean provides. Each oyster filters large volumes of water every day, consuming plankton while removing excess nutrients and impurities. As they grow, they actively improve water quality, making oyster farms one of the few food systems that benefit the surrounding ecosystem rather than degrade it. With millions of tons harvested globally each year, oysters support coastal economies while leaving a minimal environmental footprint. In a world searching for sustainable protein, oyster cages represent a rare model where food production and ocean health move in the same direction. From fragile lobster cages near shore to data-driven salmon farms offshore. From high-risk tuna ranches to decade-long sturgeon investments and self-sustaining oyster systems, floating cages have reshaped how the world produces seafood. Each species follows a different strategy, yet all rely on the same idea: controlled farming in open water can meet global demand without exhausting wild stocks. These cages are more than containers for fish. They are platforms where biology, engineering, and economics converge, feeding millions while redefining what sustainable marine agriculture can look like. As pressure on oceans grows, the future of seafood will not sink deeper into the wild. It will rise, floating on the surface, shaped by innovation, responsibility, and the choices we make today.